Good morning, everyone. It's a great pleasure for me to share with you our innovative educational activity Astro-Tamagotchi, which was developed by the National Institute for Astrophysics, named INAF. This project has been an exciting journey of integrating cutting-edge technologies like augmented reality, educational robotics, and coding to engage students and the general public in the complex world of stellar evolution. As we all know, teaching abstract astronomical concepts such as how a star are born, evolve, and die poses a significant challenge. This topic require a combination of critical thinking and imagination, and without the right tools, students may struggle to form an intuitive understanding of these vast and complex phenomena. So, Astro-Tamagotchi aims to bridge that gap. Our goal with Astro-Tamagotchi was to create an immersive learning experience that makes stellar evolution more accessible and fun. It is a gamified hands-on educational activity that was premiered at the Genoa Science Festival 2024, combining elements from well-loved games like the Tamagotchi with sophisticated scientific concepts. In Astro-Tamagotchi, in fact, students interact with a virtual star, guiding it through its life cycle, from birth in a nebula into its potential transformation into a white dwarf's neutron star or even a black hole. So we designed this activity to encourage inquiry-based learning and computational thinking by incorporating coding, augmented reality, and logical problem solving. And we create a multimodal experience where students don't just observe, they actively participate, experiment, and discover. Through this process, they learn about the formation of a star, its evolution, and ultimate fate. It's about transforming abstract scientific idea into tangible, memorable experiences. So the structure of activity is inspired by the classic Tamagotchi game. For those who may not remember, Tamagotchis were virtual pets that players had to care for and nurture. In Astro Tamagotchi, instead of taking care of a pet, students are tasked with guiding a star through its stages of development. The game begins with students adopting a protostar from a nebula. The nebula is a stellar nursery where stars are born. Using a Telegram bot, Astrotam, the students receive instruction and are given challenge that encourage them to apply coding principles to control their star development. From there, the challenges get progressively more complex, introducing scientific concepts and using augmented reality to bring their virtual star to life in 3D. This interactive AR-driven experience helps students visualize stellar processes that are typically too vast and distant to grasp otherwise. So let me walk through the main stages of the game. So the birth of a star. From here, the game begins with students scanning a welcome QR code to trigger the activity. Then they have to scan the other QR code present in the nebula and must find a suitable protostar, a young star that is already for adoption. However, like in science, where not every clump of dust in the nebula is capable of forming a star, not every QR code hides inside these images of the nebula. Represent a protostar ready to be adopted. So students must search for the right candidate. The bot will provide feedback and instruction based on the choice they make. Once they find the right protostar, the students proceed to the first challenge, lighting up the protostar. This challenge is a card game where they must combine fundamental particles like protons and helium nuclei to simulate the nuclear reaction that occur within stars. By solving this game, students can activate their star and bringing it to life. If the solution is wrong, they will have to retry the game. But if it is correct, they can proceed with the activity and meet their star using augmented reality. They can open a cryptex that contains information about the mass of the star and a QR code that once scanned will open the application called Spaces, and by using a merge cube, there is a 3D object that works with AR apps application, students can discover the type of their star. In this case, I am showing you a red star. Augmented reality activates a bot command that tells players to solve quizzes and discover the evolution of their star and its final stage. If the answers are correct, players obtain a code that must be decodified to unlock the next challenge. In fact, the final phase of the game introduces Tuozobot, a small robot that students must program to make it move through a labyrinth. The path of the Ozobot is determined by the mass of the characteristics of the star they adopted. Students use coding principle to program the robot, ensuring it takes the correct path through the maze to reach the finally evolutionary state of their star. They can be a white dwarf, a neutron star, or a black hole. At this point, students can use again a merge cube but bigger to explore the final stage of their star in even greater details. This immersive interaction brings the theoretical concept of stellar evolution into the physical space around them, making the process feel tangible. As final prize, each student receive a postcard with the images of their stars and with another QR code that allows them to see their star in AR every time they want. Once of the pins of strength of Astro-Tamagotchi, this astronomical activity lies in the integration of several digital tools, all of which were carefully selected for their accessibility and educational value. We used CoSpaces Edu to create, for example, the virtual environments where students could visualize and manipulate astronomical concepts. MergeCube brought these concepts into the physical world through AR, enabling students to interact with their star's life cycle in a way that would be impossible with traditional way of teaching. Ozobot added an interactive layer of coding and robotics, while the Telegram bot served as the central guide, providing hints, challenges, and feedback through the entire activity. This technology not only brought the star to life, but also fostered critical thinking, creativity, and problem solving, all while making the activity highly engaging and fun. The activity was very well received, but how do we know if we have succeeded in making science understood? We collected both qualitative and quantitative data through pre and post activity surveys, as well as direct feedback from students. The results were overwhelmingly positive. We had almost 2,000 participants during the Genoa Science Festival 2024, and the majority of the students reported a better understanding of stellar evolution after completing the activity. Even though only 18 filled out the post-activity form compared to 400 students completed the activity form, the comparison between the two sets of responses revealed a clear evolution in student perspective and knowledge. For example, before the activity, only 64.5% of students knew that mass was the key factor in determining a star's life cycle. Afterward, this number increased to 86.1%. Moreover, when it came to understanding augmented reality, we saw a significant improvement. Before the activity, in fact, only 44.5% of students could explain what AR is. Post activity, they had a clearer grasp of AR's potentials, demonstrating how hands-on immersive learning experiences can very well boost technological literacy, so very significant. And so the reduced number of responses in the post-activity phase may be due to several factors, such as an insufficient follow-up reminders or logistical difficulty in data collection. We don't know actually. The feedback from the students was incredibly encouraging. Many describe the activity as fun and engaging, with several highlights for the AR components. Quotes like the AR experience made it so much clearer, and it was the best laboratory experience, validated our approach and reinforced the importance of using interactive technologies in education. In conclusion, Astro-Tamagotchi has proven to be a highly effective educational tool, successfully blending game design with astronomical education. And by providing students with a dynamic, interactive environment where they can explore the life cycle of stars, we fostered both curiosity and deeper understanding of astrophysics. Looking ahead, we plan to refine and expand the activity, incorporating even more advanced technology and expanding our reach to more students. We also aim to collaborate with more educators to help integrate this tool into classroom worldwide. You can find out more on Play INAF, the innovative site for education of INAF and Universi, the official newspaper of INAF, especially the number 4 of this newspaper. You can read the article online. Thank you for your attention, and now I'm happy to answer any question you may have.